you can see that in this part these are the various locators placed to locate this workpiece, and these are the 3 locators placed inside this worksheet. So, these locators spaced as far apart as possible, these two. These are placed as far apart as possible. Whereas in this figure 2, these are the same locators placed inside this workpiece as we can see in this figure. So, the position of this locator is same as in this case. So, in these two locators case, locators spaced too close to each other. So, this is bad locating method in this case as compared to this case where these two locators spaced as far apart as possible. So, to ensure repeatability, the next consideration in the positioning of locator is the spacing of the locators themselves. As shown in this A part, this is a good arrangement for placing locators as far apart as possible. So, as a rule, space locators as far apart as practical. So, this is illustrated in this figure 12A. So, both workpiece shown here are located with the 6-point locating method. As we can see that 3 locators are placed inside the work and 3 locators are placed sidewise of the work. These are the locators placed inside this workpiece, and these are the 3 locators placed on side of this workpiece. So, only difference lies in the spacing of the locators. In this part as shown at B, both locators are on the back side are positioned close to each other. So, in the part A, these same locators are spaced further apart as possible. The parts at A is properly located. So, the part at B is not properly located. Spacing the locators as far apart as practical compensate for irregularities in either the locators or the workpiece. It also affords maximum stability. So, here in this case again we can see that these are the 3 locators placed inside this work, and these are the 3 locators placed on 2 sides of this work to restrict 6 degree of freedoms, and these 2 locators, as we can see, these locators are spaced as far apart as possible from each other. So, this is a good arrangement of placing locators, and in this case these 3 locators are same as in A case, and this locator is also same in this case, and these 2 locators are placed very close to each other. So, this arrangement is bad arrangement in this case as these 2 locators placed too close to each other. So, this is the good arrangement as these 2 locators placed as far apart as possible. So, here in this figure 13, positioning locators too close together will affect the locational accuracy. So, here if we see in this part A, these are the 2 locators placed inside this plate. These are the 3 locators placed on 2 sides of this place. As these locators are placed as far away as possible. So, this is a good arrangement of placing locators in this case. And if we see in this B part, these are the 3 locators placed inside this workpiece, and this is another locator placed on a side of this workpiece, and these 2 locators are placed very close to each other. So this is a bad arrangement in this case. Similarly, in this C part, these C locators are placed inside this work, and these 3 locators placed on 2 sides of this work. Similarly, these 2 locators are placed very close to each other. So this is again a bad arrangement in this case, which will affect the locational accuracy. So as we can see in this example, so the condition that may occur when locators are placed too close together if the center positions of the locators are misaligned. So when the spacing shown at A, this condition has little effect on the location. So what if the locating and spacing were changed as shown in figure B? So different would have a substantial effect. Another problem with locators placed too close to each other as shown in figure C. So here, because of the locators are too closely spaced, the part can wobble about the location in the work folder. So B and C are the bad plans in this case. Controlling chips. The final consideration in the placement of locators involved the problem of chip control. Chips are an inevitable parts of any machining operation and must be controlled so they do not interfere with locating the workpiece in the work folder. So several methods help to minimize the chip problems. First, position the locators away from the area with a high concentration of chips. So if this is not practically possible, then relative the locators to reduce the effect of chips on the location. So in either case, to minimize the negative effects of chips, use locators that are easily to clean, self-cleaning or protected from the chips. Again in this figure 14, locators should be relieved to reduce locational problems caused by chips. Here in this figure we can see that this is the position of the workpiece and this is the locator placed inside this workpiece. The groove is given to clear all the chips formation during the process. Similarly in these cases. So if we see in this figure the several ways that locators can be relieved to reduce chip problems. Coolant built-up can also be caused problems. So to solve these problems by drilling holes or milling slots in the areas of the work folder where the coolant is most likely to build up. So with some holders, coolant drain areas can also act as a removal point for accumulated chips. So when designing a work holder, always try to minimize the chip problems by removing areas of the tool where chips can build up. So omit areas such as inside corners, unrelieved pins or similar features from the design. So chip control must be addressed in the design of any jigs and fixture. So preventing improper loadings. So foolproof the locating prevents improper work loadings. So here in this figure we can see that these are the various locators placed to locate a workpiece. So there is a sufficient difference between these two locators. So we can say these locators are loaded correctly. So if we put the locators here in this shown in figure, so this locator is placed here instead of placing there. So this is, we can say, the bad arrangement, and these are loaded incorrectly. Similarly, in these two figures, these are the locators placed to locate this foolproofing pins, or this is in this case the better position, or we can say that these are loaded correctly and these are not loaded correctly. So for foolproofing prevents improper loading of a workpiece. The problem is most prevalent with the parts that they are symmetrical or located concentrically. So this simplest way to foolproof a work holder is to position one or two pins in a location that ensure correct orientation as shown in this figure. With some workpieces, however, more creative approaches to foolproofing must be taken. So this is the diagram for using spring loaded locators. So we can see in this diagram the spring loaded locators help ensure the correct location by pushing the workpiece against the fixed locator. So these three are the fixed locator and these three are the spring loaded locators. So this is the good arrangement in this case, where one method to help and to ensure accurate location is the installation of spring loaded pins or buttons in the work holder. As shown in this figure, these devices are positioned so their springs force pushes the workpiece against the fixed locators until the workpiece is clamped. So these spring loaded accessories not only ensure repeatable locating but also make clamping the work easier. So these are some self-assessment questions which may be important for students as examination point of view. The question number 1 may be, what is meant by locating a workpiece? Similarly, second is desirable and degree of freedom of a workpiece located in space. What is 6-point location principle? Explain with suitable sketches. Fourth is describe principles of pin locations. Fifth is what are the important points to watch respect of locations. So this was all about from today's discussion. Hope all of you will understand and enjoy this discussion. So thanks.